want to calculate the pH of a buffer solution that is 0.200 molar in HC2H3O2 and 0.1 molar in NaC2H3O2. So now when we're thinking about this, the key word here is we need to find a pH. So if we're going to find a pH, we have to have what? We have to have the hydronium ion. So which of these two would we be able to generate the hydronium ion from when we write the reaction? Well, it's going to be the acid. So as usual, we're going to start with the reaction. So I've got the acid. Remember, when it's in solution, it's in water. And I did leave the states off, so I'm just letting you know I did that ahead of time. So this is going to make the hydronium ion plus what? Well, I'm going to take a hydrogen from the acid to just get the anion. So there's my reaction. So I need to look at initial concentrations. So initially it says that for the acid I had 0.200, so I've got 0.200. Remember, water doesn't count. We didn't have any hydronium ions. However, we've got this 0.1 of this salt. Now remember, this is soluble, so it makes sodium ions and acetate ions. So I've just got the ion over here. So that's going to be 0.100. So what is the change? Well, remember, it's minus on the left, plus on the right. So I've got my x's, and then for equilibrium, what do I have to do? Well, I have to add straight down. So this would give me 0.200 minus x. This would just be x, 0.100 plus x. So that's the hard part, right? So now we're going to look at Ka. And if you remember Ka, remember some of you have memorized it by now, others have not. It is 1.8 times 10 to the minus 5. If you don't have it memorized, you just go look on your table in your textbook and you'll find it. So we do the products, so x times 0.100 plus x over the reactant, so 0.200 minus x, so got that. But wouldn't it be really cool if I could approximate that? So let's try that, because remember, it always makes our life easier. So I'm going to take out the x's that are subtracted and added. I still have the Ka constant over here on the left. So I'm going to cross multiply and divide, or you can reduce and then divide, and you should come up with 3.6 times 10 to the minus 5th. Now the question is, was it okay to make our approximation? Remember how you do that. You take that number and you multiply by the initial concentration on the left-hand side. So this is 0.200. I'm going to multiply by 100, and I'm going to get 0.018%, and that's way less than 5%, so our approximation is fine. But now remember, the number we found is actually for the hydronium ion. So I still need to find the pH. So remember, the pH equals the negative log of the hydronium ion. So I'm going to need to take the negative log of the number we just obtained, which was that 3.6 times 10 to the minus 5th. And when I did it on my calculator, I got 4.44. Remember, you want 2 decimal places when you're dealing with logarithms.